everyone, this is Elise here, and I'm really happy to be here to share with you some information and knowledge about Azure Anomaly Detector. So without further ado, I just jump into what is Anomaly Detector. So you might have heard of Azure, or you might have heard cognitive services, but do you ever heard of Anomaly Detector? So this is actually a service for several years in Azure, and this service actually will take your time series data as an input, and we are using the unsupervised model as the backend, and we can help you detect any kinds of data anomalies, for example, like specs, dips, deviations, or some trend change, or even correlation change through different products or different platform or different telemetries. So we have two main features. One is called univariate anomaly detection, and the second one is called multivariate anomaly detection. For both of the features, you can use APIs or SDKs, or most interesting part is that you can use that in other tools, for example, like Power BI, Azure Data Explorer, and Snaps Analytics, Azure Data Breaks, and also some coming soon product in Microsoft. Please stay tuned for next week for build. Okay, so next page, I will show you some scenarios. So currently we are hearing some customers, they want to define and to catch the anomalies really in time in their revenue or cost metrics, because they don't want to take too much money on several services, or they don't want to, they just want to avoid a big cost. So on the business metrics, they can apply the univariate anomaly detection to detect anomalies in real time. So every time there is a data coming in, we'll use the previous data as, like, you can understand as a training data set, but it's just a small one, and use that to learn whether the coming data, the new data, is anomalous or not. So based on that, we can give the customers output and tell them, hey, this is anomaly, and the customers will take actions immediately and to take actions on from their end. And the second scenario is the IT operational metrics. For example, you will have probably several virtual machines, or you have many different systems. And in these systems, you want to monitor from an IT operation perspective. For example, like the memory, the CPU ratio, and other some memory or material utilizations. So the IT operational metrics is also a really important scenario that our customers is facing right now. So what we recommend they do is to use the multivariate anomaly detection to detect anomalies across different correlated metrics. For example, the memory and the utilization might have some correlation with each other, but if we separate them into two parts and apply to like different anomaly detection method, then it's really hard to tell whether this system or whether this virtual machine is having some anomalies or not. So the multivariate anomaly detection is actually detecting anomalies in a system level or in a product level, which I will tell a little bit further in next slides. And the third is also a really interesting and really hot topics recently is about the IoT metrics. So in many traditional industries or companies, they are applying some like really old school methods to detect anomalies on their metrics. For example, set some threshold, just some fixed threshold on every single lines, and they will monitor them. And once the metrics or once the data is above or below the threshold they are setting, then they will receive an alert or a notification. But actually, this will have some limitations. For example, the data might change, although they are not having some anomalies, but as the time goes by, the machine becomes older, and the data or the trend will change a little bit. So the model or the system or the anomaly detection system itself have to adapt itself to the new trendings. So this is not something that fixed thresholds that can do. So that's why we are involving this multivariate anomaly detection as a service or as a feature to help customers on this kind of questions. And here is the page telling you the two capabilities in Azure Anomaly Detector. So the first is the univariate one. I also told you a little bit earlier. Is about like just detect anomalies in one single line in just one metrics. For example, the revenue or the cost or some other related metrics, or just like some usage or some traffic or some API requests. Those are also something that you can do. And we also see some customers are applying this univariate anomaly detection on some error message accounts to analyze or to get some really in-time alert on the errors. And also for the multivariate anomaly detection, you can see in this page, we are showing a picture. So you can see we are detecting on a timestamp perspective instead of every single line. So we will tell you the results, whether this timestamp is anomalous or not. So we will not only tell you that, but we will also tell you which is the root cause. Like the metric 1 and the metric 2 are the root cause, or it's the metric 3 and metric 4. And we'll also tell you whether this is because the correlation change of each other, because sometimes some metrics might have some correlations with each other. And once the correlation changed a lot, then probably this will have some impact to the system or to your product or your really expensive equipment. So this is how these two features is looking like in an overview. And these two features are actually already generally available. And then we can see in this page, this univariate anomaly detection is actually providing different APIs, and these APIs are actually detecting anomalies in different ways. The first one is the loss detection. So the loss detection is actually detect anomalies of the latest point in your time series. And the second one is the entire detect. So it's actually finding the anomalies for the entire series in batch. So you can use the first one to do some real-time or near real-time detection, and use the second one to do some validation or do some offline experiment. And for the algorithm that we are using in the univariate anomaly detection is really interesting, because we are applying like a pool of models. So we have different models like Fourier transformation, ESD here, STL, dynamic threshold, and Z-score, and also we have others. So it is actually, you don't need to choose by yourself. It's actually choose by our service automatically. So it will analyze your data trend and analyze the pattern of your data and apply a model for your data. And once your data have a really big change, like the trend change or just some really big change on the data pattern itself, we will also adapt these models to your latest data. So this is how it works and happens in as the backend. And yeah, next slide. Yeah, in this slide, I'm showing you more detailed things is from an API level, how it is looking like from the request and the response. So in the request, it's pretty simple to understand. So you are inputting some time series data, and that will include the timestamps and also the values. And you can also see some other parameters in here, like the max anomaly ratio and the sensitivity and also the granularity. That is because sometimes probably you don't want to get too many false positives or false alerts. You just want to control your anomalies in just like 25% or less than that. So this is a way that you can set in the max anomaly ratio. And for the sensitivity is actually also a thing that you can adjust the sensitivity to the data or to the anomalies. So it's actually a number between 0 to 99. And the lower the value is, the larger the margin value will be, which means the less anomalies will be accepted. And this means this system is more strict in your data right now. So this is also showing you some response in the API level. So in the response, we'll tell you whether the timestamp is anomalous or not, and whether the timestamp is positive or is a negative anomaly based on the actual value, whether it's above or below your actual exact value. And we are also showing some like period. This is something that we analyzed based on your data pattern, and some expected values, some margin, and suggested window, severity, etc. So I will not go to too much details in here, but you can definitely check out our links and documentations later. And this image, actually this animation is actually showing you how it works. So you can see there is a gray window, and this gray window is something that we call a sliding window. So every time the sliding window is actually what you ingest for this specific API call. So for example, in this sliding window, they will probably have 20 data points. So that means you are ingesting 20 data points in the request every time for every API. And then we can use the 20 data points to detect whether the last data point within this sliding window is anomalous or not. And if it is, we will tell you this is an anomaly. So this will be true and also have some other related values and results in here. So this is some demo page. If you are interested into that, I'll also paste this link in our appendix, so you can check it out later. And for the univariate anomaly detection, if you want to see how this is working with a business or data scientist team, it's pretty simple here. So you just use the variables or the metrics to detect anomalies and get the results. For the detection part, it's actually we don't use your data to training. Well, we just use your data to do inference directly, and the inference results will need to be validated by two kinds of personas. The first one probably will be data scientists, so they will probably have some KPIs that they want to meet, for example, like the precision, the recall, or some F1 score. And for the business side, they will probably want to validate whether this is looking great or making sense from their end. So this, after these two validations are passed, probably this will go to the next phase, like how to make that into a production phase and how to do more advanced features on that and how to tune the model to a better situation. Okay, so next I will show you about multivariate anomaly detection. So this feature is actually more advanced than the previous univariate one because it's applying a more complex model and it will give you more information in the results, and also it's actually solving a really big deal or really more complicated problem. So as I said earlier, this will detect anomalies from system level or from product level. So for example, if you have a really expensive equipment like an oil rig, you will probably apply several sensors, like 10 sensors or 20 sensors, or sometimes maybe 100 sensors onto that. And as we know that sensors sometimes is cheap, but some sensitive sensors are really expensive. So the cost is really high because the equipment itself is really expensive. So we don't want the equipment to be breaking down or just shut down suddenly due to some anomalies that we didn't catch in time. So actually we can detect all the sensor data together and to analyze the correlation between each other, and then to detect anomalies on the whole equipment and tell the customers whether there is an anomaly in your specific timestamp for your equipment. And here we are also listing some APIs. In multivariate, you can see we have 7 APIs right now, and probably it's a little bit hard to read at a first glance, so I just move that into this kind of visualizations. So this is actually separating our APIs into 3 parts. The first is training the model, and then getting the model status. You will use the different 2 APIs, or you can use 2 different SDK functions. The reason why we are requiring a training here is that for multivariate, because the problem is really complicated, and even though we are detecting anomalies for the same brand car, but their age is a little bit different. One is like 5-year-old and the second one is like 10 years old. Although they are just the similar same brand and the car looks exactly the same, but the data is actually looking really different between each other. So that's why we require training. And the training will based on our algorithm, the graph attention networks, and to apply to your data Python. And after you train the model, you will need to do the inference with some different APIs. So yeah, sorry for that. So for inference, we are also recommending you to do that in 2 phases. So the first phase is that you can use our batch inference API, which is also something work asynchronously. So you will first get to detect batch inference, and then use another API to get the inference results. This way is more like happening in the validation phase or in experiment phase. So for example, you will use 3 months or 1 year data to do the inference and to do some validation offline. And for the second type, or the second phase of the inference, is that after you do the validation, you think, okay, this model is looking fine, and you want to put it into production to see how it works and what's the performance when it's working in the production stage. So you can use the streaming inference API, which is the synchronized API. So every time you call this API, you will get the results immediately. But the limitation is also because it's streaming and it's working in real time. So every time we can only detect one last data point. So it's similar working stream with the previous univariate one. And for the third section is that we have some operational APIs like the list model and the delete model APIs. Right. And in the response, I'd like to highlight in here is that we will not only show you the anomalies timestamp, but we will also show you which sensors or which series are causing this anomalies. So you can see there is a contribution rank that we are exposing in the API response, in the inference response. So you can see how much every sensor or every variable is contributing to this anomalies. This anomaly. So for example, in this case, the 0 is having the largest number of the contribution score is 37%. So that means this is a top one issue that we want to focus on. But you can also check others like the series 1 or series 2 because they're also having some high numbers in here. And we are also exposing the correlation change analysis results in this response. So I will also show you later how you can use that. So one last thing in the response, sorry for switching those, my keyboard is really sensitive. And one last thing I like to highlight in here is that actually you can specify your own top contributor count. So for example, in my case is 5. So that means I only care the top 5 issues. So if you want to care more, for example, you would want to analyze the top 10, you can just specify that in your request, in your inference request body, and then you will get the top 10 contribution rank of your metrics. Okay, so this is how it works from API perspective. And then we can see some more real world challenges. So the first thing is that we know that predictive maintenance is really critical for the health of physical assets because, as I mentioned earlier, we are meeting with a really hot topic, which is the IoT metrics. So most of the IoT metrics are actually from some expensive equipment or some traditional industries. So the predictive maintenance is really a important thing or task for those industries. And the second is that the manual rule settings will not scale and adapt. As I mentioned, sometimes the traditional companies will just set some threshold for each line, but it is not adaptive because if the data change their trend, how do? They will just apply to a new threshold. It's really time costing. And you have to do that for every line and every equipment. So for example, let's imagine we have 1,000 equipments in my plant, and every equipment will have 100 sensors applied on. So that's a really huge number. It's 100,000 lines that we have to fix and we have to set thresholds on. So this is the second issue. And the third issue is that the anomalies of individual sensors will not equal to a system failure. So that means if one of your sensors is having some anomalies, it doesn't mean the equipment will be shut down or the equipment is having really big issue. It's probably just because like just a temporary fluctuation, or it's just some really small thing. It's like a false positive. So we don't want to care that sensitive on every metrics. We just want to care the health the health of the whole equipment. So this is also a challenge from a real world. And that's why we are providing this multivariate anomaly detection capabilities. So first is that we can detect different patterns of anomalies in the system, and we can detect the specs, dips, the correlation change, and others. And actually, you don't need to understand too much AI knowledge, because the model is already built for you. You can just understand how it's working for API. You just call that and get a response, and probably parsing that into some visualizations, and that will be great. That will be enough. And the second is that it's also easy to integrate into the enterprise predictive maintenance solutions with the APIs, SDKs, or our Synapse ML library, which I will introduce later. And the third is that the root cause analysis, which I highlighted for almost several times. So we will tell you when the anomalies happen, what are the top contributing anomalous variables, and why those are anomalous. So let's take a look how it's working in the workflow. So first, we can get the data, either the sensor data or some other metrics from the equipment or system, and then use our API or some other options to do the training, and then use the train model and apply the inference data side on the model, and the inference with our inference APIs, and then we can get results. So the results will also be analyzed by or validated by two different personas, the data scientist and also the maintenance engineer. After they validate from their end based on their knowledge, they can just go to the next phase, which is the production stage. Okay, so I will talk a little bit deeper about the multivariate anomaly detection best practice. So you can see here how you prepare the data. So currently we are providing two ways. So this two ways is actually based on our current investigation on the customer's use case. So some customers might store their metrics in different files or different tables. So we can just they can just providing their sensors for each table, and each table will contain the timestamp and its variables, and then zip them into a folder, and then use the folder as a URL to train the model. And the second one is one table, and this is also a really common way that the customers store their data. So they have probably one timestamp and several other variables in other columns, and that will be just one table. And the customers can convert this table into a CSV file and upload to Azure Block Storage and get a pass. So the pass will look like this. And we are also providing some best practice in this page. So first is also a really common questions from our previous customers. How many data points or how many abnormal data points I should give, or how many normal data points I should give? So our answer is that we don't have a really hard threshold. Let's say if your abnormal ratio is above 2 or 5%, you cannot train. No, definitely no. It's just a recommended. So you should put as much as you can for normal data, because the way that the model works is that we will learn how it's looking like in your training data. So how it's looking like is actually how the normal data is looking like. So if you give enough normal data, so the model will learn, okay, the normal data will look like this. And when you give an anomaly data in the inference, then the model will see that as an outlier, because the model doesn't see that before, right, in the training data side. So that's why we are recommending that you try your best to give as much as the normal data into the training data side. This is the first one. And the second one is that you should feed as much as the training data, and above 5,000 is really good to learn. The reason why is that we do some experiments. For example, like just 100 data points might not have a really great analyzed results. And also, if your granularity is really fine, like your granularity is milliseconds, then 5,000 data points might not be enough, because the 5,000 might not cover the really common data pattern in your data side. So try to cover the data pattern like 2 or 4 cycles or more than that, that would be great. And try to give as much as you can for the normal data. And the third is that we also accept this continuous data, even though you don't have a really apparent granularity or something like that. Is that because we just analyze the data as each data point, so we don't have to align the other timestamp to be continuous. So you can definitely have some missing timestamps, and you can also have some missing data points, because in our training method or in our training API, we are providing the missing data points, the field NA method for you. So you can just choose one that you like, for example, like the fixed method or the zero method, or just not field actually. So these are something that we can help you to do for the data pre-processing part. And for other data pre-processing that we are recommending you to do is, first, exclude the data as system downtime or uptime and out of service data. So just to remove those and to make this data set a little bit cleaner. And the second one is exclude the data around restart time, because per our customers, many restarting time will cause many aberrations. So they will probably be marked as anomalies, but actually it's not. So one way that you can do that is that you will probably have another matrix called on and off. So it's like a binary thing or something like that. So you can base on that to understand, one is the time that your system is restarting, and once it's restarting, probably you just skip the restarting time, and based on your own knowledge, probably the restarting time will be 2 hours, 20 hours, or more than that. So you can base on that to exclude the data in that time range. And the third one is that the timestamp should be properly aligned for multiple variables through some aggregation methods or some reindex methods. Hey, if you remember the picture that I showed earlier for the multivariate one, you will see that we have multiple lines and we have a timestamp. So every timestamp should have some data in there. So that's why we want the timestamp should be better aligned with each other for different or multiple variables. And the last thing is actually an optional pre-processing method that you can do some feature engineering work, because also per our customers' best practice, some of them are actually doing some feature engineering because they have a really big data scientist team. So they are doing a lot of experiments, like take 1 or 2 years, and they think some metrics probably will not be a really good thing to train, and probably the combination of 2 or 3 of the metrics will be better. So they're just doing something like this, but it's just optional, because we are also seeing in most of the case, the customer is not doing the feature engineering work, and the model and the service is working really well on their end. Okay, so this page is actually showing you the flow and also some the best practice in the result analysis. So probably the result in here is too small due to the font size, but what we can see here is in the response is also a JSON format. So you will have the different timestamps, and you will have the results for the every timestamp, whether it's anomalous or not, and the root cause behind that. And for the best practice in the results analysis is that we have some features, we have some parameters to help you sift out the anomalies that are severe in your case, and this can avoid too many false positives. And another thing is validate models. There are actually some ways. So the first is that in the training response, after you train model, you will have a training loss and a validation loss. So you can base on these two sets of numbers to understand how the model is doing right now, and whether you want to retrain on a new data set or this is already okay. And the second one is that you can do some calculations yourself, some machine learning metrics with your label. So for example, like some precision, recall, and F1 score, if you have your label in that, you can definitely use that to do some comparison between the label and the results. But it's also okay if you don't have labels, because our training and inference doesn't require the label at all, because we are using the unsupervised model as the backend for the whole Azure Anomaly Detector service. And the third one is that you can validate manually using the previous severe events. So this is also some big customers actually doing, because they don't have labels for every timestamp. It's really time costing, and it really costs a lot of human labor resource. So what they're doing is that they will probably have some logs or some historical data telling them, or noting in there, saying for example, the January 1st or the May 18th are having a really big breakdown for the equipment or for the system. So they can, based on this kind of big severe events, and to compare that with the results and see whether the service is working in a good way and can catch those kind of disasters events. Okay, so these are some best practice on the results analysis. And then this is actually a reference architecture that's showing you how to combine everything together and how to connect the training, the inference, and also the downstream components. So first, you can collect, or gather your sensor data from your equipment and store them into the blob storage. And then you can training based on that, and the data path actually is the thing that you upload to blob storage. You just copy the URLs. It's really simple. And then use the training data path to train. You have different options, which I will also show you later. So you can choose one of the options that you are most familiar with and train a model. Then to use another set of the data to do the inference. You can either use the asynchronous inference or use the synchronous inference, but these two different inference is actually having two ways to prepare the data. So if you are using the asynchronous inference, the payload or the request body will be too much, because you may want to ingest like 3 months or 1 year or 5 years data to do the inference, right? So it's really impossible to ingest all the things into a request body. So what we recommend is that you should prepare this kind of inference data in the CSV file similar to the training data set, and then upload them to a blob storage and copy the URL as your inference data path. And second way of the inference is that you can do the synchronized inference. So the synchronized inference, because it's like in real time and we want it really quick, and every time there will not be like too many data points, so it's acceptable that we put the data points into the request body. So the input in here is actually the JSON format in the request body for synchronized inference. And then you will trigger different inference based on your option or your preference, and then you can get the results. You can store them in some storage, or you can just directly use the alerts and notifications to help you set up some alert system. And you can also see the visualizations or create your own visualizations in the Power BI. And you can also use the function apps to parse the data, and also use some Power apps like Power Automate to trigger some notification or trigger some automatic things like the inference or some others. So this is how we are looking for from the reference architecture. And the next is the most interesting part in today's session, is that we will show you 5 popular ways to use the anomaly detector. So anomaly detector is not only the APIs or SDKs itself, it can also be leveraged in different platforms. So you might be really familiar with all these icons. So the first is Azure Machine Learning. So in Azure Machine Learning, currently you can use retro code in that. And the code is just a really simple notebook. You can just copy from our GitHub repo or just copy from the link here. So we are providing the code, and you just copy the code in Azure Machine Learning, and you can schedule some pipeline, because there are having some pipeline either in code or on the studio, you can use that to trigger the training and trigger the inference really frequently. And the second option is that you can use the anomaly detector in Azure Synapse Analytics. So for univariate and multivariate, we are also having some ways to use that in this workspace. And the third is that you can use the features in Azure Databricks as well. And the fourth is that you can use in the Power BI. And the last thing is that you can use in the Azure Data Explorer. Just kindly noted that these two features are only in the Power BI, are only for univariate anomaly detection. It's not for the whole features, but we are trying to extending to more features in future. Okay, so if we see that in a reference architecture way, it's pretty similar to the previous one, right? So we can choose one of them as the option to do the training or do the inference or just do the univariate anomaly detection, and to store the detection results and metadata storage in like Azure Event Hub or at storage. And you can send some alerts and notifications using the Azure Logic apps or Azure Notification Hubs, and do the visualizations and implement them into different ways like the Power BI and Power Apps and other app services. Okay, so I will go a little bit deeper for each option. The first option is that you can use in Azure Synapse Analytics. So if you ever tried with that, you can see in Azure Synapse Analytics, especially in the workspace, there is a part saying Azure Cognitive Service, and you can choose the anomaly detector, and that will lead you to a page. It's really simple because this is like a really low code way. You just use around 20 lines of the code that you can set some names of the output columns, and then you just click run. And in the run results, you can see whether the timestamp is anomalous or not, and whether it's a positive anomaly or a negative anomaly, etc. So this is the first one. And the second one is that you can use the multivariate and univariate both in a more advanced way. Is that you can write a code in that because we are integrated into Synapse ML library. So it's an open source library, but is in the Synapse brand, and in future it will also be in a new product name. And in the Synapse ML, you can see here, first you need to do some configuration, and then you just import the modules from Synapse ML. And then you can just run some simple code to do the training, to do the inference. The workflow is pretty similar, but the code is less than calling the APIs or SDKs directly. And the second option is that you can use in Azure Databricks. The reason why is that in Azure Databricks, you can also import the Synapse ML library, because the Synapse ML library is actually based on a big data calculation. It's based on Spark environment. So you can, if you have a really sensitive requirement, or you just want your data to be calculated and to be detected really quickly or more quickly, you can choose that. And also for the data resource, if you're using the Synapse ML library, the resource is not that limited, because if you're using the APIs or SDKs, we are only supporting the Azure Blob Storage as the input. But if you're using this library, you can use any kind of data source that Spark supports. So this is the second option. You can see it's also writing some like simple codes in here, and you can see the results, and you can also schedule your pipeline in here. Probably you just want to schedule every day calling inference, and every 2 weeks or every month to run the training. So this is the second option. And the third option is that you can run the anomaly detector in Azure Machine Learning, because Azure Machine Learning is also a good way to manage your model, manage your service, and eventually manage your pipeline. So you can write, for example, like a training Python notebook, and also to write inference notebook, and use the pipeline either in the code way or in the studio to do that, to schedule a regular inference or a regular retraining. So this is a third way, and it's also, I think it's a really popular way across our customers, because many customers are actually using the Azure Machine Learning right now, and Azure Machine Learning are having a lot of capabilities around the machine learning, either the open source or some like built-in tools. So it's really powerful. And the fourth is that you can also use the anomaly detector in the Azure Data Explorer. So if you use that before, you can either use that in web or in desktop, which is called the Coastal.Explorer. So in that, it's actually a built-in function for the univariate anomaly detection. The multivariate is not there yet, but you can start from the univariate. And in the univariate anomaly detection, you just call the built-in function, and then you will trigger the inference in real time based on your schedule or how frequently you will query your data in the Coastal. Okay, so this is the fourth option, and here is the screenshot in the desktop. So you just enable the plugin and enable the policy, and then you just use this built-in function called the series UV anomalies FL, and then to put some endpoint and some key of your Azure Anomaly Detector. I'm not sure whether all of you guys have experience with Azure service, but in most of the Azure service, it's actually you should first have an Azure subscription, and then use that subscription. You can go to the azureportal.com to create different resource. So for example, if you want to create an anomaly detector, you just go to the Azure portal and search for an anomaly detector, and under your subscription, you create a resource, and in the resource, you will have the endpoint and the key. You just paste them in here so that you can call the API directly. So the last function is that you can use in Power BI, because the Power BI is a really popular tool or a product in many business metrics, especially for some revenue or returns, or some I may use something like that. This kind of data analysis, many people tend to use the Power BI to do that work. So in Power BI, if you're using a line chart, a single line chart in here, you can see we have a find anomalies function. So this find anomalies function is actually embedded the univariate anomaly detection. So you don't need to call the API yourself, but just use this function and choose the ones that you want to detect anomalies on, and then you will see the results and whether it's marked as gray or not. So this is the 5 interesting ways of the Power BI, and you can also change the sensitivities. Like you can change the sensitivity from 90 to 80, or even to a lower or a higher thing. That the sensitivity is also a parameter that I introduced earlier in our slides. And you can also explain by a specific field, and you can also define your own shape or specify your own shape for the anomaly, and also some visualization related settings. Okay, so this is how it's looking like by explained by different fields. So you can also export this or add this explanation reports into your dashboard. So we are also providing an icon in here. And another thing in Power BI is that you can not only use that built-in tool, but you can also use our Power Query, because the Power Query is a more powerful thing that you can use in the advanced editor. So in that, you can just run a piece of code, it's just a simple code, and to query the data and to call the API itself. So we also have some practice and some documentation related to that, and I will paste that in the appendix later. So in that way, you can do more customized way, and you will get more insights, like the results analysis and the root cause analysis and the severity, etc. So Power Query is a more advanced feature if you want to use anomaly detector in Power BI. So this is something that we are drafting. So we can see we will have the value, we can have the upper margin, the lower margin, the expected values, all the response in APIs you can definitely get in this Power Query method. Okay, I think basically that's all for today's content, and we are also providing some different materials like joining our team channel, and we're also providing some documentation related to today's talk, and some blog, and also some GitHub resources. And for the five interesting parts of five interesting ways to use an anomaly detector, you can find them in the last link, aka.ms/AD material. So in that, you will find the GitHub with a lot of useful links. Okay, I think that's all for today, and we can have some time to do the question and answer session.